Hey everyone, now that we have established how to create a null and alternative hypothesis, we're going to take a look in the next few sections at how to conduct a test to either accept or reject that hypothesis. There's a lot of assumptions that we need to have, and a couple that are pretty standard across all the different types of hypothesis testing, and we're going to see them kind of validated in this problem. If you take a look at this problem, we've got an automobile company that has a claim that its gas mileage for a van is 362 miles per gallon. So that I know right away is going to be my null hypothesis, that the average gas mileage is equal to 36.2. Now, that's my null hypothesis. I need to figure out what my alternative hypothesis is, and then I'm going to have to create a test statistic in order to test for that. So the independent testing firm came in and they tested 220 vans. That's important because you need to test, in order to use these ideas, you have to have more than 30 in your sample size. They found a mean of 36. So they ended up with an average in this sample of 36, and they have a variance of 4.41, which means I'm eventually going to need the standard deviation, and I shouldn't label them that way because that is in a sample. So the sample variance, oh no, I just take that back. It says assume the variance is known. That is the population variance, and that's actually the one that we're taking a look at here. What do you do if you know the population standard deviation, which is relatively rare, but if you do, that's what's going on. Remember, the population standard deviation is the square root of the variance. So the square root of 4.41 is 2.1. So that's my standard deviation. There's my average. And I'm going to use a significance level of alpha is equal to 0.05. That's how significant do I want this to be. And remember, that alpha really relates back to those critical values we looked at in confidence intervals. In this case, I have a picture over here that shows you if I have looking for a statistical significance at the 5% level, those are my standard deviations of splitting that in half. Here would be 95% of the data, and then 2.5% on either side. Now that's for a two-tailed test. And I know this one to be a two-tailed test because they have said they just believe that it is incorrect. They didn't say we believe it's higher or we believe it's lower. We're just saying we think it's incorrect. So our alternative hypothesis is that the mean is not 36.2. All right, so now what do we do with all of this? The first step is going to be to create a test statistic. That test statistic really should look familiar. It just ends up being our z-scores from before. So when you know the standard deviation, the z-score is going to be calculated just like we've done it before. X bar minus, notice this is mu sub 0, divided by the standard deviation of the sample in this case. And remember, the standard deviation of the sample, this part right here, is going to be the standard deviation divided by the square root of how many people are in it. So let's take a look at what we have with the numbers that we've got here. My null hypothesis, I know that the average that I had gotten in my test minus the average that I claimed, that's going to be these two numbers. The 36 was the average that I tested, and the 36.2 was the claim. So I've got 36 minus 36.2 divided by, and I'm going to do this separately. I have to take that standard deviation, and I have to divide it by how many people were in here. And I can't remember that one. That one was 220. So I'm going to say 2.1 divided by the square root of 220. And that equals 0.14151, and you can do this a little bit differently. Typically I would do that all at once, but this number is going here. So I have negative 0.2 divided by 0.1416. And I get a value of, I'll move this over here, I get a value of negative 1.41. That is my z-score. So let's see what this means. If my z-score is negative 1.41, I am looking at this and saying I end up right about here. This means that there is a 95% chance that this is going to happen. What we really say is that in that middle section, that's where we fail to reject it, right? It's really, really rare. It's very uncommon for things to get further away from what we expect. So this says, yeah, you tested 220 vans and it wasn't 36.2, but the probability of that happening is still well within the range, 95% confidence interval here. So I'm not going to reject it. So in this case, we would say that I am not going to reject the null hypothesis, and I'm going to assume that they are still correct. They're still true. Now, keep in mind, this uses a critical value of 1.96. Where did that 1.96 come from? If you recall, whenever you're looking at critical values for a standard normal table, a lot of times you are going to be given critical values that are either in a one-tail or two-tail. So here, because I was using a one-tail or a two-tailed test, the critical value for a two-tailed test, 1.96. If it would have been a one-tailed test, it would have been 1.645. It still would have been less than that, and I still would have rejected it even if we were just saying like, oh, we think it's higher. But for the two-tailed test, we use that critical value. You remember you'll have a lot of different types of questions where they will ask you to do this with different setups here. So we'll take a look at one more. This problem, an engineer designed a valve that will regulate water pressure on an automobile engine. The engineer designed the valve that it would produce a mean pressure of 6.4. Once again, I can see this, a mean pressure of 6.4 pounds per square inch. That is my claim. My null hypothesis is that the mean is equal to 6.4 pounds per square inch. It is believed that the valve performs above the specifications. So my alternative hypothesis is that the mean is greater than 6.4. Now remember, this is a one-tailed test. I'm not saying it's different. I'm saying it's greater than. And so when we go back to that chart and say I need to find a significance level, and I'll pull this over here, when we look at this, we are going to say, well, what significance level are we looking for? And we're trying to prove this at a 2% significance level. So 98, which is 2%, on a one-tailed test is going to be 2.05. So alpha equals 0.02, and my critical value is going to be 2.05. Now I'm going to go through the test before. Again, if I know the standard deviation, which I do, it says assume the standard deviation is known to be 0.9. I need to know how many engines. So 130 engines, an average of 6.6, a standard deviation of 0.9, and I am going to immediately find the standard deviation of that sample by saying 0.9 divided by the square root of 130. I've got 0.0789. And I'm going to use that same z-score test that I used before and say, well, the test value was 6.6 minus my assumed value of 6.4 divided by this 0.0789 will give me a z-score of 0.2 divided by 0.0789, 2.534. Now, this is higher. So if I'm thinking about that test here, like here is where the 2.05 is, right? And I'm thinking of a one-tailed test. I'm only interested in if it's going this way. I've gone beyond that, and my test statistic is over here. It's in really rare category. So in this case, I would reject the null hypothesis. I would say that the mean pressure is not 6.4. In fact, the mean pressure is higher than 6.4. Now, we would have to probably do more tests to see, could we find what it is? What's our claim going to be now? Maybe we say that it's 6.5. We do another test and sample, and we determine whether or not we could disprove that until we get to the point where we say, yep, we're pretty sure that this is the mean pressure for this water valve. But that is how a null hypothesis and an alternative hypothesis test for both one tail and two tails is going to work if you know the standard deviation of the population, right? So this formula is how you will calculate that z-score, and you will compare that z-score to the critical value that you need in order to either reject or accept the null hypothesis.